zindimtima umo. Tiende pamodzi ndimtima umo. Tiende pamodzi ndimtima umo. Tiende pamodzi ndimtima umo.
Welcome to MTN Teleschool. With me, your presenter, my name's Prince Siwale. I'm very much delighted to be part of this great innovative program. Today, I will revise with you Chemistry 5070. A few questions have been selected from different past examination papers, and today we're going to break together the bonds that are so hard in chemistry, so that each and every one of us can see a very good performance at the end of this session. Thank you very much. So we're quickly going to go into our first question, which is question number 1. The question reads, the diagram below shows 4 sets of apparatus used in the laboratory. So you can see there are 4 sets of apparatus which are used to demonstrate different separation techniques. So the question is, which of the following letters A to E corresponds to each of the following? A, residue. But before we can answer that question, it is very important that to know what is this substance classified as a residue. A residue, this is a solid left over after filtration process. And as we can see from our diagrams there, we realize that the residue in that case is calcium carbonate, because it is a solid that has been left on the filter paper after filtration process. So question 1A, the residue is D. Let's look at question 1B, sublimate. What is a sublimate? A sublimate, this is a solid deposit that forms when a gas has been cooled via sublimation process. But it is also important for you to know, a sublimate is formed if maybe a mixture of 2 substances, one that sublimes and the other one which does not sublime, have been mixed together. We can heat the mixture. That mixture of a substance which contains a substance that sublimes and that which does not sublime is going to give us a sublimate. In this case, we have been given a mixture of a salt and naphthalene. Naphthalene being a substance that sublimes, it is going to sublimate on that cool surface and to be collected as the sublimate. So in that case, apparatus number 1, the sublimate is naphthalene, which is A. So we can write the sublimate is A. Let's move on to question C. Saturated solution. It is important for us to know a saturated solution is a solution in which normal solute can dissolve at that particular temperature. So in this case, we're observing that in apparatus C, the growing crystals of copper 2 sulfate in that solution are not anymore dissolving, which gives us an idea that the saturated solution in that case is C. So we can write the saturated solution is C. Let's move on to the next question, a filtrate. a filtrate, this is a solution that passes through the filter paper filtration process. And as we can look at the fourth set of apparatus, there is a residue which I've already discussed, the calcium carbonate, and there was a solution that was passing through the filter paper. That solution passing through filter paper during the process of filtration is known as the filtrate. So in that case, the filtrate is salt solution E. Salt solution E. Let's look at the last question on question number 1. The question says a distillate. A distillate, this is a liquid that has been collected and condensed during distillation process. So as you can see on our second apparatus there is a substance which is colorless liquid B. At first, the brew solution was heat. After being heat, it produced a colorless liquid B collected and condensed. That is our distillate. So our distillate is E, is B. Viewers, you're watching MTN Teleschool. Forget not to invite your family and friends so that together we can learn chemistry as we prepare for this year's October-November examination. Without wasting much of the time, we're now going to go into question 2. Viewers, the question reads, the flowchart below shows the reaction of zinc carbonate and dilute sulphuric acid. When zinc carbonate has been reacted with dilute sulphuric acid, it forms water, carbon dioxide, and a salt solution of compound A. When a solution of compound A is mixed with acidified barium nitrate solution, a white precipitate B and solution E are formed. Identify the substances A, B, and C by name and by formula. Before we can get into answering this question, let us first write an ionic equation for the given reagents. They are then going to help us to understand what the products would be. So question 2, there is a reaction of zinc carbonate plus sulfuric acid, H2SO4. When these two react, there are 3 products formed. We're going to form a salt solution of compound A, which in this case will be zinc sulfate. So this is going to be compound A. Also, what will be formed is carbon dioxide because we're reacting it with a carbonate. Apart from that, we're also going to form water, which is H2O. Okay. Now, we realize that in this case, our compound A is going to be zinc sulfate. So that's zinc sulfate. We've been told zinc sulfate is reacted with acidified barium nitrate. Barium nitrate. When zinc sulfate is reacted with acidified barium nitrate, we form 2 salts. We're going to form barium sulfate a solid, which is a precipitate in this case. We're also going to form zinc nitrate. Okay, there's a 2 there. I hope you're able to see it. Now, we're told that a white precipitate forms. So the white precipitate in this case is going to be barium sulfate. So this is a white PPT, white precipitate, PPT 4 precipitate. Also, what forms is solution C. So the solution C in this case is zinc nitrate. So class, let us now answer the question now that we know what will be formed when the 2 reagents are mixed. So the question says, identify substance A by name and formula. So we can say from here that A is the name. The name there is zinc sulfate. And the formula for zinc sulfate is ZnSO4. Remember, the size of the the zinc, sulfur, and oxygen, they should all be the same. Don't write capital Z and small s. They are different elements, so they should have the same size in terms of when writing the formula. Number B. We realize that B is the white precipitate. In this case, the white precipitate is barium sulfate. Barium sulfate, which is a white PPT. Its formula is BaSO4. Also, we've been told to identify substance C. Substance C in that case class is zinc nitrate. Which is Zn, open brackets, NO3, 2. Class, we've identified the substance A, B, and C by name and by formula. So it means we've scored 6 marks. Have you seen how easy it is to score in a chemistry exam? All you need to do is to follow the given instructions. Viewers, we are watching MTN Telescope. Thank you very much for tuning in. Invite your family and friends as we continue to do our revision process. We're now going to go into question number 3. The question reads, Epsom salt is a commercial or trade name for hydrated salt of magnesium sulfate crystals. The crystals are formed from a solution of magnesium sulfate by a suitable process. A pupil wishes to prepare Epsom salt in its pure dry form by starting with an insoluble solid reactant X with a non-dilute acid Y. Give the name and formula of acid Y. Before we can answer the question, class, the salt that we're preparing is magnesium sulfate crystals, whose formula is this. So, to know the formula of the acid that is used to prepare this salt, it is very easy. The anion in this sample, which is the negative ion, is going to guide us to know the acid that was used to prepare the salt. In this case, we are preparing magnesium sulfate. So, we have to look for the acid that contains a sulfate. We all know the acid that contains a sulfate is sulfuric acid. So class, to answer the first question, The name is sulphuric acid because of the sulfate present in the salt. So the name of the acid is sulphuric acid, and the formula is H2SO4. That is the formula of the acid used to repair magnesium sulfate. Let's move on to the next question, which is question B. The question reads, give the formula of any three possible reactant to be used as solid C in this experiment. Now, we realize that magnesium sulfate is a soluble salt. So there is a standard method that we use to prepare soluble salts. In this case, if you are preparing a salt which is soluble other than a salt of potassium, sodium, or ammonium, there is a standard method we use, which is we react, we use action of an acid on a metal. B, we can also use action of an acid on a metal oxide. We can also use action of an acid on a metal carbonate. We can also use action of an acid on a metal hydroxide. Now, since we know the method to use, we're told here to write the formula of any three possibilities of solid X. So this is going to guide us. So now, since what we're using is we're preparing a salt of magnesium, in this case we're already guided that the method to use is magnesium. So in our guide, we're going to say one of the possibilities of X is magnesium. It can also be magnesium oxide, magnesium carbonate, and magnesium hydroxide. So what there's metal, just replace with magnesium, it gives you the possibilities of the solid C. So the question is very specific in this case. It is saying give the formula. So the formulas will be as follows. Number one, we can use magnesium oxide. Remember, the question does not say name, it says the formula. So we just write the formula. Number two, we can also use magnesium hydroxide. Number three, we can also use magnesium carbonate. So this class are the three possibilities of solid X: magnesium, magnesium hydroxide, and magnesium carbonate. So without wasting much time, we're quickly going to look at question C. The question reads, when X is reacted with Y, a gas which taints lime water mucin is produced. C1. Use this information to construct a balanced chemical equation for the reaction of X and Y, including state symbols. In that case, we have been given a guide. We have three possibilities of solid X, but there is a guide there. It is saying there is one of the reagents which will give us a gas that turns lime water milky. In that case, we know that the reagent to use should contain a carbonate. So we're going to use magnesium carbonate to react with acid Y. So the equation is magnesium carbonate solid plus H2SO4 aqueous produces magnesium sulfate aqueous plus carbon dioxide gas plus H2O liquid. Remember, the equation is saying a balanced chemical equation. For a balanced chemical equation, there are three elements that we consider. One, the chemical formulas used should be correct. The state symbols used should also be correct. And also, the stoichiometric coefficient should be able to balance on both sides of the equation. Now, if you can look at this equation, realize that the atoms are balancing on both sides of the equation themselves. So for you to score a mark for balancing, you have to write that the equation is self-balanced. Only then can you score a mark for balancing. So that is the equation class for the reaction of magnesium carbonate and sulfuric acid to form magnesium sulfate, carbon dioxide, and water. Let's move on to question C2. So this was C1, C2. The question reads, the pupil deliberately adds more of the solid X to 100 cubic centimeters of 0.1 molar per cubic decimeter of acid Y. Explain why the pupil chooses to use the solid in excess. So 2A, here the pupil chooses to add the solid in excess in order to neutralize all the acid. So we're going to say that A, the reason is to neutralize or use, okay. So to neutralize or use up or the acid. And remember, we stop adding when no more of magnesium carbonate can dissolve. That's when you stop adding. So let's look at question C2B. The question reads, what separation technique must the pupil use at this stage to obtain the solution of magnesium sulfate? The separation technique that can be used in this case, you observe that this magnesium sulfate, it is in solid state. So it was added to acid Y until no more of it could dissolve. So because it was added in excess, meaning that there's going to be a remainder of the solid that was in excess. So now, that solid excess in the solution can be separated by the process known as filtration. So we can add, the process is filtration. Okay, we're now going to look at question question B3. The question reads, the crystals of Epsom salt, magnesium sulfate heptahydrate, are then corrected from the solution of magnesium sulfate. The following steps are involved, not in their order. Number 1, filter. 2, dry the crystals. 3, heat the solution. Number 4, allow the solution to cool slowly. Arrange these 4 steps in their logical order for the dry, pure crystals of magnesium sulfate heptahydrate to be corrected from magnesium sulfate. So now, these are the steps of crystallization. The order is going to be as follows. The first step when crystallizing a solution is we have to heat. So number 1, we heat. So the purpose of heating, we heat the magnesium sulfate solution in order to form a saturated solution by evaporating some water. Number 2, we have to cool. So we cool the solution to allow crystals to begin to form, or we cool for proper formation of well-defined crystals. Number 3, after I've cooled and crystals have begun to form, the next step we need to filter. So we filter to obtain crystals separate from the mother liquor, the solution where the crystals are in. Number 4, we can now dry the crystals. So the last step is we dry the crystals to have a pure dry sample of the hydrate, magnesium sulfate heptahydrate. Viewers, you're watching MTN Telescope. Remember to invite your friends so that we may revise together chemistry as we prepare for this year's exams. Please stay put. We're quickly going to go into a short break. We're going to be back and we're going to continue with the revision process. Thank you very much for watching. Stay tuned.
I told the bus driver that I work hard for my money, so it better gets to Chipata.
Yeah, that's right. That's what I told him.
Yeah.
Weather, drama no, only Zambili.
Tituma. And he kept trying to tell us something, but I was like, Ukagamba, Tilo.
Cause cash money yave across Zambia.
Tituma. At Basi and Kuchpat. The end of South Africa. Hello, what?
Run, K-Star, run! You got the bus.
Sending money doesn't have to be this dramatic. Open an MTN mobile money account today and send money to friends and loved ones across Zambia instantly. Dial *303# to send money with MTN, Zambia's #1 network. With MTN mobile money, Tituma.
MTN. Everywhere you go.
Enyimbo chinapera ekyalo omwewo.
Without music, our lives would be lifeless.
Music gives the mind wings.
Music refreshes the soul on this journey of life and never dies.
It's who we are. I mean, it's what we do.
It's what we feel.
What would we be without music?
The future of music streaming is MTN Music Plus.
MTN. Everywhere you go.
Thank you very much, Brian, there. We received the love. Oh, thank you very much, our very own CEO, Mr. Charles Mlapisi. Isaac Kapera Jumbe. This is a great innovation. Thank you very much for your support. Together we can reach far. Mukuka Simeo, thank you very much for the love. Let's keep it up. Mukuka Simeo. Maxwell Ngambi, thank you very much for your support. Our very own and supportive Nono Musumba, thank you very much for the love. Thank you. So I'm now going to go back to our revision process. Thank you very much for your support. Okay, we now continue with our question. We're now going to look at question D on question 3. That is 3D. The question reads, excess of solid X is used or added to 100 cubic centimeter of 1.0 mole per cubic decimeter of acid Y. Calculate the mass of the crystals magnesium sulfate heptahydrate expected to be produced in the experiment. In this case, what we're first going to do is we have to find the moles. Because remember, for us to find the mass is equal to number of moles over molar mass. So we cannot find the mass of the hydrate if we do not know its moles. So what we're going to do is we're going to write an equation, one of the possibilities of solid C and sulfuric acid. We can even use magnesium oxide. So magnesium oxide solid plus H2SO4 aqueous produces magnesium sulfate plus H2O liquid. Now, we have been given 100 cubic centimeter of the acid. We've also been given 1.0 mole per cubic decimeter of the same acid. So what we're going to do is we're going to use this information given to find the moles of the acid. Remember, Number of moles in terms of concentration and volume N is equal to concentration times volume. In this case, the concentration is given as 1.0 mole per cubic decimeter times the volume. Now, remember, this volume given, it is in cubic decimeter. Therefore, it is our responsibility as chemists to convert this to the necessary units, which is cubic decimeter. To do that, we divide by 1,000. So I'm going to say 100 divided by 1,000. This converts our units to cubic decimeter. So number of moles of H2SO4 in this case is equal to 1.0 mole per cubic decimeter times 100 divided by 1,000. It will give us 0.1 cubic decimeter. Thereafter, we can now multiply 1.0 times 0.1. It will give us 0.1 mole. The cubic decimeter and the cubic decimeter there, they will divide. So we have that the moles of the acid that reacted in that case is 0.1. Again, if you look at the equation of magnesium sulfate, I mean magnesium oxide and sulfuric acid, these are reacting in the ratio 1:1. So because the mole ratio of the reacting species is the same, the number of moles for the species involved is also going to be the same. So from this, we deduce that the number of moles of magnesium sulfate crystals will also be 0.1. So I'm going to say mole of magnesium sulfate heptahydrate crystals is equal to 0.1 mole. Now that we know the moles of magnesium sulfate heptahydrate crystals, we're now going to find the molar mass of the salt as follows. So the elements present there, I've got magnesium, sulfur, oxygen, and hydrogen. We realize that there's only one atom of magnesium, so it is 1 times the molar mass for magnesium. Remember, magnesium is Mg2412. So the molar mass is that number on top, the 24. So it is 1 times 24, giving us 24. Sulfur, there's also one atom of sulfur, so it is 1 times 32. 1 times 32 class, we're going to get 32. We also have oxygen atoms. Now, here we have to be very careful. Remember, there are 4 oxygen atoms. There's also this 7 on the hydrate, mean to be 7 plus 4, making them to be 11, times the molar mass for oxygen, which is 16. We can calculate that. 11 times 16 will give us 176. Hydrogen. The number of hydrogen atoms present in this salt is 7 times 2, which gives us 14. So it would be 14 times 1. And we all know 14 times 1 will give us 14. Thereafter, we can do summation of the results. So we have that 24 plus 32 plus 176 plus 14. This gives us 246. Remember, molar mass, relative molecular mass has no units. It is a ratio, but molar mass has units which are grams per mole. Now that we know the molar mass of magnesium sulfate and the moles of magnesium sulfate, we can easily find the mass of the crystal. So we can say mass of magnesium sulfate heptahydrate is equal to mole times molar mass. Let me just take you back. We had already calculated the moles of magnesium sulfate, which is 0.1 mole. So the mole in this case is 0.1 mole times the molar mass. The molar mass, which is, remember, molar mass has units which are grams per mole. 246 grams per mole. The mole and the mole will divide, giving us the mass of the salt as 246 times 0.1. The result is 24.6 grams. So this is the mass of magnesium sulfate crystals. Hope you're following. Remember, invite your family and friends. You're watching MTN Telescope. Let's continue with our revision process as we look at the last question on question 3, which is D2. It reads, calculate the percentage yield if 20.0 grams of magnesium sulfate crystals is actually obtained. Remember, percentage yield. So this is now D2. Percentage yield is equal to actual yield divided by theoretical yield times 100%. So the actual yield in this case has been given as 20.0 grams divided by the theoretical yield is that which we're just from calculating, which is 24.6 grams times 100%. Remember, the gram and the gram will divide. So we're going to have 20 divided by 24.6 times 100, giving us 81.3008131. Remember, all our answers, just like we've been given, there should be one DP, one decimal place. So in this case, our final answer for the percentage yield is going to be 81.3%. That is all on that question. Thank you very much. We can now look at question 4. The question reads, the diagram below shows apparatus used to electrolyze concentrated potassium chloride. So the first question is, so we can see there the electrolyte is concentrated aqueous potassium chloride. Okay, so I've got potassium chloride concentrated. So the question is, suggest a suitable material for the electrodes. So the suitable materials can use are those that are inert or unreactive, such as we can use graphite. We can also use platinum because they're inert. B. Write an ionic equation to show the formation of the gases at A and at B. So it would be interesting to find out, before we even answer the question, what ions are present in this concentrated potassium chloride. Remember, for concentrated and dilute aqueous solution like potassium chloride, we're going to have 4 ions. We're going to have potassium ion. We're also going to have a chloride. So this is aqueous, meaning that also those ions from water, which are hydrogen ion and also hydroxide ion. Now, we want to know which gas will be formed at A. So as you can see our A, it is the anode. The anode, this is the positive terminal or the positive electrode. The anode being positive, it is going to attract the negative ions. But we have a challenge here. We've got 2 ions that are negative. There is a chloride and there's also hydroxide. How then do we know which ion is going to be discharged or which ion will get attracted to the anode? Remember, under electrochemistry, for the release or the discharge of ion, there are 3 principles that guide us. Number 1, the position of the ion on the electrochemical series. Number 2, the nature of the electrodes. Number 3, we also use the concentration can guide us, can help us know which ion is to be released. In this case, we're using concentrated potassium chloride. So meaning that we've got more chloride ions which are concentrated. So the chloride in this case is going to get attracted to the anode, which is A. So we can write A. So A is the anode. So the anode being positive, it will attract the chloride, which is greater in concentration. So I'm going to have chloride aqueous. This one loses electrons to form Cl2 gas plus electron. So I'm going to balance it. So this is an ionic equation showing the formation of the gas at A. B, remember the B is the cathode. The cathode being positive, it is going to attract positive ions. In this case, hydrogen is going to be attracted to the cathode because it is lower, it is less stable compared to potassium ion on the electrochemical series. So we're going to have hydrogen ion aqueous, gaining an electron, forming H2 gas. So we balance it, 2 there, 2 here. So that is the equation for the formation of the gas at B. So we're done with question B1 and B2. So this was B1 and this was B2. Let's look at C. The question reads, explain why potassium metal is not formed at the cathode in the electrolysis. So potassium metal is not formed because potassium ion is more stable. Hence, the hydrogen ion is preferentially discharged. D. Write the overall equation for the electrolysis of concentrated aqueous potassium chloride. So remember, we've got potassium chloride aqueous in water. We've already discussed the two gases produced. It is a chloride, chlorine gas, and hydrogen gas. Plus, remember in the solution we had the potassium that was not attracted to any electrode and also the hydroxide. So they'll form potassium hydroxide aqueous. Okay, this is AQ. So this is the overall reaction for the electrolysis of concentrated potassium chloride. So now, thank you very much, viewers. We're going to continue with our revision process as we look at the last question. But do not forget to invite your family and friends so that we revise together. Thank you very much. Let's quickly go as we look at the last question, which is question number 5. The question reads, common metals extracted in industry include aluminium, copper, and zinc. A. Copy and complete the table naming the ore, method of extraction, where the ore is extracted from. So we have that. So there's an element there. So the first element is aluminium. So this aluminium is extracted from its ore, which is known as bauxite. Bauxite. Okay. And the method of extraction is known as electrolysis. This aluminium, it is above carbon on the electrochemical series, so it is extracted by electrolysis. The next method there, it is copper. The ore that we can use to extract our copper from is known as copper pyrite. Now, here you have to be very careful. On the methods of extraction, it is not correct for a student to just write reduction. We should specify whether it is electrolytic or chemical reduction. So for you to score a mark here, You have to write that this is extracted by chemical reduction. Otherwise, if you just write reduction, you lose the mark. So it is chemical reduction. Or we can also use roasting of the metal. Number 3, we have zinc. Zinc is extracted from its ore, which is known as zinc blende. Zinc blende. Or we can also use calamine, which is zinc carbonate, calamine. And this zinc is extracted from zinc blende by a process known as chemical reduction. Thank you. We can now look at question B on question 5. Which of the metals in the table is quickly coated with an oxide layer when exposed to air, making it unreactive? The metal in that case is aluminium. It is the one that forms an oxide layer, which is unreactive. Number B2, bronze is an alloy. Which two metals are alloyed to produce bronze? Remember, an alloy is a mixture of a metal with another metal. So in this case, to produce bronze, we're going to react. We mix copper and tin. These, they form bronze. State 2 reasons why alloys are preferred to pure metals. Since alloys are a combination of metals, it means that alloys are stronger than pure metals. That is one of the reasons why they are preferred. So we can write alloys are stronger than pure metals. Number 2, also alloys have a high resistance to corrosion. Okay, we can now look at the last part of the question, which is D. 2 of the metals in the table form oxides which react with acids and alkalis. What products are formed when the metal oxide react with an acid and an alkali? Class, when a metal oxide react with an alkali, with an acid and an alkali, we form 2 products. We're going to form a salt and water. Number 2, write an equation for the reaction when one metal oxide reacts with dilute hydrochloric acid. In this case, we can use a metal oxide such as zinc oxide plus the acid given in this case is hydrochloric acid, HCl. This produces zinc chloride, aqueous, plus H2O liquid. So that is the balanced chemical equation for the reaction of zinc oxide and hydrochloric acid. Thank you very much, viewers. Thank you for watching. Thank you for your support. Thank you very much for your love. Remember, don't forget to invite your family and friends. We're having the next session at 16 hours. Please stay tuned. Once again, my names are Mr. Siwale, your tutor in Chemistry 5070. Have a blessed and wonderful time. Thank you.
Tiende pamozi ni mtima umo. 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 Tiende pamozi